In the previous section, we explored integers.
Boy, did we.
We looked at the operations of addition, subtraction, multiplication, division, and the expression of large integers using scientific notation. The next type of number we'll look at is decimals. Decimal numbers are not whole numbers and can be either positive or negative.
Section A, the decimal point and decimal places.
We've said several times so far that each digit place represents multiplication by a power of 10. The same is true to the right of the decimal point. The decimal point is to the right of the units place. It's in every number, but it's not written with integers. That is, the number 42 could be written as 42 with the decimal point after the 2. But it's a little cumbersome to do this.
The decimal point represents the separation of the units place and the tenths place.
The place to the right of the tenths place is the hundredths place. To the right of the hundredths place is the thousandths place, and so forth.
For example, the number 52.3 is read as 52 3/10.
Addition, subtraction, multiplication, and division for numbers with decimals are a lot like addition, subtraction, multiplication, and division with integers. The important difference is that you have to keep track of the decimal places you're working with.
Decimal points are good. Decimal points are good. Decimal points are good. Decimal points are good. Section B, addition and subtraction with decimals.
When you're adding or subtracting decimals, the decimal points for the numbers you're adding or subtracting must line up. For example, if you want to add the numbers 56.3 and 7.89, then the decimal points for each number must line up.
For this problem, we line up the 6 and the 7 because they're both in the units place of their respective numbers. Now that the numbers are lined up, we can add them just like we did with integers, carrying when needed. To help with addition, we can place a 0 to the right of the 3 without changing the value of the first number, since it is to the right of the decimal.
What do we mean by that?
Well, look at these two numbers. In the first number, the zeros could be dropped without changing the value of the number. The number is still 56.3 after we dropped the zeros. For the second number, this is not possible. The second number is 56 billion.3. If we drop the zeros, it would be 56.3.
All the zeros are important in this number. All the zeros between the 6 and the 3 affect the size of the number because the zeros are to the left of the decimal.
Now that we've put in a 0, let's go back and add. Come on. Come on!
Our first step in the problem is to add the numbers to the farthest right in the hundredths place. 9 plus 0 equals 9. Moving to the left, we add 8 and 3 and get 11. We put a 1 in the tenths place of the sum and carry a 1 to the units place.
As we said earlier, it's important to keep the decimal points lined up.
So we just bring down the decimal point to right here, the exact same place, one level lower. Now we finish up by adding the rest of the numbers.
7 plus 6 is 13, plus the carried 1 equals 14. The 4 goes in the units place, and we carry the 1 to the tens place. Now we add the carried 1 plus 5 to get 6. The 6 goes in the tens place of the solution, and presto! The answer to our addition problem is 64 19/100ths.
Subtracting with decimals is done in the same way as adding. The most important thing to remember is to line the decimal points up.
Section C, multiplication and division with decimals. For multiplication and division of numbers, you must also keep track of the decimal places. If you don't, they'll muck up the whole thing, not to mention your carpet.
Multiplication of decimals is done exactly the same as multiplication of integers. One number is set on top of the other, and each digit of the bottom number is multiplied with all the digits in the top number, with the appropriate zeros put into each result. The results are then added together, just like with integers.
So why are you saying all this again? Isn't this just more cumbersomeness?
No, you need to take one additional step when multiplying decimals.
You have to count the total number of digit places to the right of the decimal point in all of the numbers that are being multiplied. Then, you move your product's decimal point that number of decimal places to the left from the right end of the product.
So if there are a total of 4 numbers to the right of the units place and the numbers being multiplied, then the decimal is put 4 places from the right end in the product. Let's do an example.
1.86 times 2.3 is calculated the same way as 186 times 23. After we've gone through the steps in calculating a multiplication problem, the product, or answer, is 4,278.
Now we need to adjust our product for the decimal points.
There are 3 digits to the right of the decimal points in both numbers being multiplied. So we have to insert a decimal point 3 decimal places from the right end of our product. That means the decimal point is located between the 4 and 2. The answer is 4 and 278 thousandths.
Division of decimals is also done exactly the same as division of integers, except we move the decimal points before dividing.
We'll divide 1.45 by 0.5. Oh, God. Whoa. Oh.
1.45 goes inside the division sign since it's the dividend, or number being divided. 0.5, or 5/10, goes to the left of the division sign.
The first step anytime you divide decimals is to move the decimal point in the divisor all the way to the right, so that the last digit of the divisor is in the units place.
The decimal point in the divisor, or 5/10, must be moved 1 place to the right. That way, the divisor's last number on the right is in the units place.
The second step is to move the decimal point in the dividend the same number of places to the right as we move the divisor.
So we move the decimal point in the dividend, or 1 and 45/100ths, the same number of places to the right as we move the divisor. We moved the decimal point in the divisor 1 place, so now we move the decimal in the dividend 1 place. Our division problem is now 14.5 divided by 5.
Now we just go through the normal division process.
Here's our division problem. The 5 can't go into 1, so we have to include the next digit in the dividend, 4. The 5 goes into 14 2 times. 2 times 5 equals 10, and it goes beneath the 14. 14 minus 10 equals 4. Now we bring down the 5. 45 divided by 5 is 9 with no remainder. So after dividing 5 into 14.5, our quotient is 29.
Our last step is to insert a decimal point into the answer, above the decimal point in the dividend.
The decimal place directly above the decimal point in 14.5 is between the 2 and the 9. This leaves us with a quotient of 2.9, or 2 and 9/10.
Don't forget, you move the decimal point after you multiply. You count the number of digits to the right of the decimals you're multiplying, then put the decimal that number of places to the left in your final result. You adjust the decimal point before you begin the problem in division. For division, you move the decimal in the divisor to the right of the unit's place. Then, you move the decimal in the dividend the same number of places.
Section D, rounding off with decimals.
Rounding for decimals is similar to rounding for integers, except you can round off numbers to the right of the decimal as well. The steps for rounding off positive decimals are the same as the steps for rounding positive integers. You find the digit place you want to round off to, then oh, look, it's a ladybug. Your second step is to look at the number to the right of that digit place. If it is equal to or greater than 5, then round up the digit you're rounding off to. If it's less than 5, you don't do anything. Here's another example.
Look at the number 3.814, or 3 and 814 thousandths.
We can round this number to the nearest units place to get the integer 4. That's because the number to the right of the units place is 8, which is greater than 5. so we round the units place digit up 1 from 3 to 4. Our answer is 4, and there's no need to insert a decimal point in this type of answer. You can see that the process of rounding off doesn't change even though the number has a decimal.
So rounding 3.814 to the nearest tenth is 3.8, or 3 8/10. And rounding to the nearest hundredth gives us 3.81, or 3 81/100. In both cases, the digit to the right of the one being rounded off is less than 5, so the digit being rounded off cannot be raised 1.
Notice that we didn't put zeros to the right of the last digit. The value of the rounded number doesn't change either way.
Section E, scientific notation with decimals. Decimals are often used in scientific notation. Remember, in scientific notation, we're dealing with powers of 10. All we're really doing in scientific notation is moving the decimal point enough places so that the number we're multiplying a power of 10 by is between 1 and 10. And the number of places we move our decimal point tells us what power of 10 we multiply by.
We can use scientific notation to show the distance from the Earth to the Sun, 144 billion meters. We move the decimal place to the left so that the number remaining is greater than or equal to 1 and less than 10. For our number, we move the decimal point over to the left until it's between the 1 and the 4. Our decimal point is now 11 places to the left of where it was. So the answer would be 1.44 times 10 to the 11th power. Notice that 10 to the 11th power is 100 billion, and 1.44 times 100 billion is 144 billion meters.
So up to this point, we've been moving the decimal point to the left, and the power of 10 was the number of decimal places we moved. For numbers less than 1, we have to move the decimal to the right in order to make the number in the units place between 1 and 10. The power of 10 is still represented by the number of places we move the decimal, except the power of 10 is made negative. For example, we'll put 0.0003789 into scientific notation. We must move the decimal 4 places to the right to make the number in the units place between 1 and 10. After moving the decimal point, our number is 3.789. Our power of 10 is negative 4, since we moved the decimal to the right 4 places. The answer is 3.789, or 3 789,000ths, times 10 to the negative 4 power.
Don't forget, to use scientific notation for large numbers, your exponent will always be positive. To use scientific notation for numbers less than 1, your exponent will always be negative.
Quiz 3.